Zeke and 6 of his friends are going to a baseball game. Their combined money totals $28.50. At the game, hot dogs cost $1.25 each. Hamburgers cost $2.50. And sodas cost 50 cents each. Each person buys one soda. They spend all $28.50 on food and soda. Graph your equation on the grid below. So they want us to write an equation that can determine the number of hot dogs, X, and hamburgers, Y, Zeke and his friends buy. So the first thing I want to do is tackle that soda problem. Now, the trick is you got to remember Zeke is a person. So we're not talking about just the 6 friends. We're talking about 6 friends plus Zeke. So that's 7 sodas that they buy at 50 cents each. So we're going to subtract that from our total, and $28.50 minus $3.50 gives us $25. So now I can come down here and write the equation. 1.25x plus 2.5y equals 25. And I want to go straight to my graphing calculator and graph that function. So, home screen, new doc, say no to drugs, and add a graph page. Now, I misspoke by calling this a function. Technically, I'm going to graph this as a relation because I don't want to have to solve it for y. So I want 1.25x plus 2.5y equals $25. And enter. Now, I know that my line is up there somewhere, but I'm going to use the trace feature this time anyway. So menu 5, 3. I want to set my trace step to 1 and say OK. Now, menu 5, 1 does a graph trace. And if you look right down here, it tells me the first point on my relation is the point 0, 10, and it shows me where that point is. So when I arrow to the right, I get 1 and 9.5. 9.5 is silly. You can't buy a half a hot dog. You're either going to buy an entire hot dog or they're not giving you one. That's what's going to happen. So we don't want the point 1, 9.5. That doesn't help us. We have to go over and take 2, 9. And then we're going to go over and take 4, 8, 6, 7, 8, 6, all the way down to the edge of the graph when we get to 20 and 0. So that's where I find all the points on this graph that I have plotted in our video. Now, when I look at all these points plotted on my graph, notice that there are actually 11 different points that represent combinations of hot dogs or hamburgers that they could have purchased. And all of these points have whole numbers for the X and the Y. And that's the requirement. They have to be whole numbers. We can't include all the decimals that might end up on this line in between all our nice lattice points. So the final step is they say, explain your answer, and they want a sentence for that explanation. So our explanation is all combinations must have whole numbers for hot dogs and hamburgers. And that is full credit for question number 9.